So, section B, physical fieldwork inquiry, which will come after your unseen fieldwork. Our physical fieldwork inquiry is: does hard engineering control longshore drift at Hornsea? So, this was when we went in year 10, at the end of year 10 in summer, when we went to Hornsea Beach and we walked along the beach and we looked at the groins and we looked at the terminal groin syndrome. So, what do you need to know? You need to know why it was suitable for us to go there. You need to think about the risks and how we overcome them, how we collected data, so specifically how we collected data along the groins and we did the field sketches. The data presentation, so that data we collected along each groin, how did we present that when we got back to school? An overall conclusion. So, what did our data show that could have proved our hypothesis that it did control longshore drift? And the evaluation. So, what went wrong on that day? What did go right on that day that helped us? And overall, what would we do again if we were to do it to make it more reliable and more accurate? So our hypothesis and our aims were we believed that the groins at Hornsea were going to be effective. We believed there was going to be more sediment on the north side in comparison to the south, so therefore it's catching it and reducing longshore drift. It was a good place for us to go, so it was suitable for us to go for our physical inquiry because that place is affected by longshore drift. We know that because we have our spit at the end of it, which is material that has been taken down in that zigzag formation. As a result, the beach is good because it helps tourists, and the local council have installed hard engineering methods of groins, and there was also rock armour and there was a seawall and there was also some soft, but we don't need to worry about that. But the area is also accessible by coach. It is the closest place to our school that has those hard engineering strategies. So, thinking about our risk assessment then, the tides, obviously, we had to consider the tide timetable would have been looked at, risk of powerful waves, risk of drowning. We told you to not go too close to the shore and stay out of the sea. We looked at tide timetables. Cliff collapse, we were walking along. We know that it is soft rock along the Holderness coast that is eroding very quickly. That is what the beach is actually protecting behind. And we did that by avoiding you walking near the foot of the cliff, and we were told to keep away a well back. And then the weather, could it have been really wet, so therefore it had been dangerous and slippy, or could it have been really hot, so we could have had dehydration? So bringing appropriate footwear, making sure we've got water, we've got sun cream on. So one side is what is the risk, and the other side is how to overcome it. This has come up in the last couple of years in this way. So suggest one reason why risk assessment was important when planning your inquiry. And then for one of your inquiries, outline why it's important to complete a risk assessment. They are two very similar questions, just worded in a different way. Both questions are 2 marks. So for your 2 marks, you'd say what the risk is for one and then how it was overcome. So thinking about how we actually collected data, so we used a meter long ruler stick and we did systematic sampling and we visited about 8 groins. We used the meter ruler stick from the bottom to the top of the groin and we repeated it on each side. So we had a table for a north side and a south side and we wrote it down from the top of the sand to the top of the groin. The strengths of this, it clearly showed whether it was working or not because we should have had more sediment on one side versus the other. The method of data collection is quite simple to carry out and does not need special equipment. And it was quantitative, which means we could create averages or a mean, which is good for our data. It's good when we are writing a conclusion. Our weaknesses, though, we did not maybe take those measurements at the same point along each groin, and several were maybe not taken along each side. And there could have been human error. We might have read the meter ruler stick wrong, or we might have sunk it into the sand or not held it straight. It's really important to consider that we only measured 8, so is that enough to reach a reliable conclusion? This has come up in the exam previously by asking assess the effectiveness or one or more data collection methods for your physical fieldwork environment or inquiry. If you are assessing, you need to consider the advantages the disadvantages, then tell the examiner and use words like it was effective, it wasn't, at gathering data, and then come to a judgment in the end. Tell them how much you think it was effective or it was not effective. So, like a mini conclusion. We presented by a dual bar chart when we got back to school. We did at 8 different sites, but our data was not continuous. Therefore, we decided it was better to do it as a bar graph. If you want to look at my unfamiliar fieldwork, I talk about discrete and continuous data there. It was a good way to compare quantities of sediment. Patterns could be easily identified, and we could work out an average for the north and the south side. And we put that at the bottom so it was easier to remember. And then conclusions. This is where you discuss what patterns show if it proves your original hypothesis that hard engineering does control longshore drift. So thinking about that final question and evaluation, which is what went well, what didn't go well, and what are you going to do next time to make it more reliable and more valid. What's really interesting is in these 3 questions are from the last 3 years, and they are very, very similar, meaning it is more predictable when you go into paper 3. So to what extent did the data collected for one of your inquiries help you reach a valid conclusion? To what extent did the data help you obtain accurate results and a valid conclusion? And to what extent did the results and conclusion answer the inquiry question or hypothesis? They are very similar. They are worth 9 marks, and you need to structure it as we've suggested. I'm going to talk about it in a second. So, for paragraph 1, I would state your conclusion and I would explain how the data you collected helped make this valid. So, for example, I might say something like, this is more basic because I can't fit it all on one slide, but the location helped the validity of my conclusion. The data we collected was in Hornsea, where there was lots of hard engineering strategies, including groins, which meant I could collect lots of it, which made it more reliable. Then I would discuss another positive thing that helped your results, that helps the overall conclusion that it does work more valid, more reliable. And then paragraph 2, what didn't go so well that might have impacted the reliability or the accuracy. So, however, to some extent, human error when collecting the data may have made the results more inaccurate. The ruler may have stunk in the sand when measuring from the top of the groin to the bottom. Therefore, the results we got may not be as reliable because if it was to be repeated, it may not be consistent. So remembering what that word reliability means. And I would discuss another negative of the inquiry. And then paragraph 3 is like your conclusion, but it's what you would do again. So state what you would do to improve and make your results more reliable. So to make my results more reliable and accurate, which help the validity of my conclusion. So as you can see, I'm kind of rephrasing the question on my first sentence there. The groins are effective at stopping longshore drift. I would repeat the study on numerous occasions throughout the day, week, or year to address issues such as the amount of data collected. So could we go to more groins? Or when longshore drift may or be more or less affected, such as in the winter. This then means I have a bigger sample size as the tide could have been coming in, which meant some areas were restricted. And the smaller your sample size, remember year 11, then it is not going to be as reliable and as accurate. Check out my human geography video if you haven't already and the unfamiliar fieldwork. You're going to smash it. Well done.